Alright, a vertical tower stands on a horizontal plane. Let's draw a vertical tower. Stands on a horizontal plane. And is surmounted, or on top of it, is by a vertical flagstaff that is 5 meters. So this flagstaff is 5 meters. At a point on the plane, anywhere you want it, the angles of elevation of the bottom and the top of the flagstaff are respectively 60 and 45 degrees. Find the height of the tower. So find the height of the tower is in blue there, so I'll call that H or X. It's the unknown. Okay, so what about these angles? In your projects, hopefully I get to you guys Monday, you're going to have to use hopefully some technology. And this technology will kind of help you understand how to use this. So I'm going to point this over a little bit. Alright, let's pretend I put my measuring device down. It reads 0 degrees. Now let's say, let me think. North, south, east. What's to the east? Angel Stadium. What do you guys call it? The Big A? Sure. Angel Stadium. Let's say it's way over there, right? And let's just say I'm going to put this at the very top of measure of the Big A. Do you think the angle is going to be very small or very big? If I put my eye and try to aim at it. Since it's so far away, if you take the absolute value, that angle is going to be what? Very small. But let's pretend someone gave me free tickets to the Angel Stadium, right? And I'm there in the parking lot. And then I aim my phone to the very top. What do you think it's going to be? Small or big? Like, I'm right next to it, right? So the angle is going to go up really fast. Okay? So this idea of angles being very small from being far away, and the angle being very big when it's close is important to us. So, we have the top of the flag and the bottom of the flag. Okay. What angle do you think that's going to be? Small or big? Oh, sorry. This angle right here. So I drew to the top and to the bottom. Do you think the angle is going to be small or big? Smaller, right? Alright, pay attention for this one. That means you're looking there, right? And then you move up. Now pay attention. It's from the horizontal to that one. And how much is that angle going to be? 60 degrees. It's going to be bigger, right? That's right, 60 there and 45. So that's the first step. We drew one triangle. Okay, next thing I need to do is I need to make now 2 triangles. Let's see if we can draw these triangles side by side. I don't know. I left all the space on this side for the longest math problem of the year. Three, six. 2. Alright, I'm going to pause here And with your partner, I want you to talk about how did we label the first triangle. And then I want you guys to see if you guys can label the two triangles. I call it small triangle and the big right triangle. And then see if you guys can label it, okay? Alright, so let's label this two triangles together. This is my small triangle. How many degrees is our angle? 45. Okay. How about this one here? Is this going to be blue or blue and red? It's just the small, so that would be just blue. And we call that X. And we did say, if we color coding in this, the ground was purple. Tell your partner why this triangle looks funny. What do you have and what you don't have? Talk to your partner. 10 seconds. Ready, set, go. Class, can you use Pythagorean theorem? No, you don't have two sides. Can you use trig ratios? You have a starting point, but you are missing more side lengths. You're missing a number, right? You usually would have like a 16 or a 20 there, right? All right, let's label the big one now. What's my angle? 60 degrees. The angle is 60 degrees. Okay. Tell me about this side. What colors? Yeah. It's the blue plus the red. Now, the common mistake is just to call the whole side length 5. But 5 only represents the flag. As one student shouted out, this would be X plus 5. This length is X, and this is 5, so it's going to be called X plus 5. Well, we're missing something. But we do have one color in common. They also have the purple. Let's call that Y. So we have two unknown variables. We have to solve this by linear systems. You guys remember that? Just say yes, Mr. Alright, this is what I want you to do. Clarify any questions your partner has about the two triangles. And I want you guys to set up trig ratios based on this here. And then I want you to solve for Y. Solve for Y. What does that mean? Get Y by itself. Make it where it says Y equals. Okay? You guys have 3 minutes. Ready to go. Vita, pick one, left or right? Okay. What's your angle? From here, what side do you have? Which trig ratio? Tangent. Tangent of 45 degrees, and the sides? Correct. Raise your hand if you got that so far. Awesome. Alright, I asked you guys to solve for Y, so we're going to have to get Y on one side, and it has to be in the numerator. So Kiana, can you help us get this Y by itself? What do you want to do? Yep. Yes. What do I get? Yes. Chen, how do I get y by itself? Nice. And there is what I wanted. Y equals x over tangent of 45 degrees. Raise your hand if you got that. Good job, good job. Alright. Let's try this triangle now. Help us, Jesse V. What's your angle? Trig ratio. Y is a tangent. Opposite side is? Yep. Yep. Cardo? How do I solve for y? Yep. 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 Yes. What are you left with? Yep. We got it. Alright, let's recap what we've done so far. One triangle, separated, two trig ratios, and then we solved for y. Linear systems, because they're both equal to y. See if I can explain it. Every time I see y, I can write x plus 5 over tangent of 60. On this side, I see y. What can I write here, class? X plus 5 over tangent of 60. So I'm basically taking all of that and just putting it right there. This is called solving linear systems by substitution. So I have x plus 5 over tangent of 60 equals x over tangent of 45. Let's solve for x. Did you see what happened? We went from two variables now to one variable. It was eliminated by substitution. Alright, buckle your seatbelts. I have a proportions. I can just use cross multiply to get rid of the fraction. Let's see what happens. I get x plus 5, keep the x plus 5 together, times tangent of 45 equals x times tangent of 60. Now I need to get the x's together. But in order to get the x's together, I can't just divide by x and cancel x's. We can't do that. So here I'm going to have to distribute. Class, what am I doing? Let's distribute. I have x tangent 45 degrees plus 5 times tangent of 45. And I made a big deal about the what? Plus, because in the super long problem, students always made this mistake. They would always change this to multiplication. So you have to distribute, that will be a plus. And this side is the same. Alright, let's get the x's together. They belong together. To get these x's together, I can go this way, or I probably want to move it this way. So I'm going to subtract x tangent 45 from both sides. Do not be tempted. These are not like terms. You cannot do x tan 60 minus x tan 45 and get x tan 15. That would be incorrect. So now I'm left with this. 5 tangent 45 degrees equals x tan 60 minus x tan 45. Class, what do you notice about both of these terms on the right side? They both have a tangent or x. So what do you think I'm going to do? We're going to take out a GCF. What does GCF stand for? Greatest common factor. So I have x tan 60 minus tan 45. And on this side, 5 tangent 45 degrees. We're almost there. What math operations here? Multiplication. So if I do division, then I can get x by itself. So tan 60 degrees. So you're basically dividing both sides by all of that. And this whole thing cancels. And you're left with a calculator-ready equation. X equals 5 tan 45 over tan 60 minus tangent of 45. Alright. This was such a long problem, I'm going to cut my losses. You can go for the home run and put all that into your calculator and press enter and hopefully get the answer. Or you can cut your losses or minimize your losses by just putting in like tangent of 45. Tangent of 45. We talked about using rounding to lots of decimal places. Oh, look at that! Tangent of 45 is just equal to 1. That's nice. Right? Every time it says tangent of 45, I'm just writing 1. And then tangent of 60, 1.7321. And then now you can go for the home run. 5 times 1 is just 5. And then I'm going to divide that by 1.7321 minus 1. And this gives me an answer. Da-da-da! Didn't tell us for it around, so I don't know. 6.83 meters sounds fine. And that's the answer! How'd you guys do in the longest math problem of the year? Yeah, the video's probably going to be like 20 minutes. Okay. I'm going to summarize what we did, and then I'll talk about some alternatives. I was given a word problem. Draw one triangle, separate it into two triangles, solve for y, substitute them together, and then basically you're solving for x. Here are some alternatives. And has anyone noticed the numbers 60 and 45? What makes those? Are they normal or special? They're special right triangles. So we could have just not used trig and use special right triangles. But to force you to use a trig, I'll probably change those numbers to like 42 degrees and 63. Does that make sense? And the other one I can't really think of. So there it is.